Afternoon, everyone. Welcome to the Sleepy Go Bye-Bye after lunchtime slot. I shall try to keep people awake. So this talk today is about Kubernetes. You'll kind of see quite a lot of nautical imagery. Docker and Kubernetes projects seem to love the analogies to do with like shipping containers. They've taken it really far. So Kubernetes is Greek for steersman. So I thought, well, that's a good opportunity to find some nice pictures to put in the presentation. Just before I get started, I'm guessing heard of Kubernetes is a yes. Use Kubernetes, like tried it out. Okay. Running it in production? No, because brave people running it in production. Fantastic, excellent. So hopefully some of this will be interesting. And what I'm going to do. So I got involved in Kubernetes about just over a year ago. It was about middle of summer last year, and it was how I usually get involved in new things, which was a client came along and said, you know about Docker. So people said, oh, right, you can go and talk to people about Kubernetes. And I said, what? So I did a bit of reading and tried to work out what this Kubernetes thing was. And after a while, I found some stuff which was quite interesting, or it was interesting to me, about how this product was being developed. And that's where this presentation came out of. Really, it was from my explorations around Kubernetes and things I've found that could be interesting if you're looking at it, or things I've found that might be interesting if you want to break into it. So if you're a security tester, you might start running into this stuff on a day-to-day basis, and it's there's some stuff to know. But that's what this is about. Very brief about me. I've been in security for a large number of years. I'm a managing consultant at NCC and contributor at Security Stack Exchange. People heard of Security Stack Exchange? Sorry, I'm asking the question to start with. Yeah? Cool. So if you haven't heard of it, it's really useful. It's like Stack Overflow, but for security questions. And there's lots of helpful people there who are happy to answer questions. It's a good place to go if you have questions. I'm also a contributing author to the CIS, Docker, and Kubernetes standards. So there are a couple of standards. One of the things I noticed when I started looking at Kubernetes was there was very little documentation about security. So luckily a guy started up a standard for it tail end of last year, and we've got that version. It's actually up to date with the latest version of Kubernetes now 1.7. So that's kind of worth looking at as well. I'll talk a bit more about that as we go through. What are we going to talk about today? Start off with Kubernetes architecture. How does this thing actually work? I'm going to go into a bit about that. I also think it's really important, you're getting to a new topic, is you have to understand how it works before you can understand how to break it. Or it's a lot easier if you do understand how it works. So it's worth going and doing a bit of high level, bit of talk about that. We're going to talk about deployment options. Because one of the things I found out when I started looking at this was there isn't just one way to roll this out. There's lots of different ways. And it really matters when you're coming to look at it in terms of security, how it's been rolled out. Threat model. If no one attacks my system, it doesn't really matter how secure it is. So who is going to attack a Kubernetes cluster? How might they want to attack it? So we're going to try and walk through some of the common attack scenarios and see how someone might break into something. And key security concerns. No point in talking about how to break into it if I can't talk about how to fix the problems. So we'll talk about some of the settings you should look at if you're deploying this to make it a bit more secure. What is it? First thing to start off with. So the Kubernetes website will describe it as an open source system for automating, deploying, scaling, management of containerized applications. It groups containers that make up an application into logical units for easy management and discovery. And isn't that a mouthful? Basically, it's a way of letting people who want to deploy an application and they want to deploy it on a cluster of containers and they want to have a nice scalable system and they want it to just work. And they don't want to have to worry too much about how the underlying cluster does its job. They want to just deal with it at a high level, say, here is a system. I want now to scale this, I want to make it work, I want to upgrade to a new version, and I just want it to work. And the idea is Kubernetes kind of takes away a lot of those concerns in theory, abstracts them away, and lets you as a developer, if you're a developer of a system, not have to worry too much about them. So that's theory. Project background, just to give you a bit where it's come from. Started by Google in 2014. So Google run everything they do in containers, and they had a internal system called Borg. Basically, some people said that it would be really nice if there was an open source outside version of this Borg thing. So some people from Google started Kubernetes in 2014. In 2015, it got its 1.0 release, so the very first public version. So it's pretty new. We're talking like sub 2 years. I think it actually hit its 2-year anniversary, the first public release just now. And it's managed by something called the Cloud Native Computing Foundation, which you might well not have heard of, but all the big cloud players are involved. So Microsoft, Google, Amazon, Red Hat, IBM, you name it. If you're involved in cloud stuff, they're probably members of the CNCF. And there's a whole load of projects of which Kubernetes is probably the biggest that come under their banner. And rapid deployment and rapid adoption. It's fair to say that this is a very quick moving project. Basically new releases every 3 months, which is a nightmare if you're a security person, because it means things change every 3 months. And you've been telling someone, giving some advice, new version comes out, and suddenly that advice doesn't work anymore because something's changed. And rapid adoption is fair to say as well. When I started looking at this, I was actually quite surprised because companies from financial services, so a bank called Monzo, they use Kubernetes, and they've been talking about how they've used it for quite some time, publicly. So they're big users. That's getting used to there. The UK Home Office are big users of Kubernetes, and they've done presentations publicly about how they use Kubernetes. So used in the public sector. It's also used in places like Walmart and Ocado. Both recently did announcements about how they were moving to Kubernetes. So they were deploying a lot of their applications. So we're seeing a lot of industry adoption of this. This isn't just something that some people are playing with. We're seeing large companies really getting into this stuff. So let's talk about the architecture. Let's talk about how it all works. First, however, I'm sufficiently mad to try and do demos. So let's do some demos. Okay, I have got a cluster. I'll use this command, kubectl. It's basically how you interact with clusters, the Kubernetes clusters, pretty much. At the moment, I don't have any services. So I just have the Kubernetes service. Now that's the service that has to run to make the cluster work. So it's just sitting there. What I can do is I can say kubectl create -f example. And it'll go away and it says, hey, I'm going to create some stuff. Now, how did it do that? What it did, if I can find example.yaml, here we go. Basically, everything in Kubernetes land uses YAML. So what you do is you chuck YAML files at the server and you say, I'm going to tell you how this application is defined in this YAML file. You will go and create it for me. And what I just chucked at it was this. And this basically has a series of containers, a series of applications, and it defines how they work and how they interact with each other. And now, if I go here and I do kubectl get service again, kubectl get service, you'll see I've got all the services. And I've got a port here of 30652. So if I go in here, and here, and I do, go to my Kubernetes one, and I do, what was that port? 30652. 30652. We get a guest boot, and that's my application. So that's run up 2 instances of front end and some Redis slaves and masters from that YAML file. And I can say, here's a message, and it'll take the message. And then the interesting thing is, if I go to another node in my cluster, node 2, it exists there too. So it's exposed and it's worked out how to route, and it's routing that traffic into my cluster to one of the application nodes, and it's doing all that for me, and I don't actually need to know, where those containers are running. I don't need to know how they work. I just need to tell it to do its stuff. And I can say, hello. And it does it. So it works quite nicely. So you can see why people like that, right? If I'm a developer and I want to deploy something, and I can say to an ops guy, or I can say DevOps style, I'm just going to deploy this, and you pass it to that, and away you go. Great, excellent. Works really nicely, as did my demo, which is always nice. Right, so I don't need that, because that video failed, which it didn't. So a little bit about some terminology, quickly. It's worth kind of covering off, because I've started using terminology already, and it's worth mentioning what they are. Containers, if you've not already come across them, it's basically a packaging mechanism for an application that gives you an isolated way to package up an application in a standard format. Docker images are the default standard. There are others. However, most people, when they talk about containers, are talking about Docker images. A pod. Kubernetes has the idea of a pod, and a pod is a group of containers that work really closely together. So they share a network namespace. So if you deploy multiple containers inside a pod, they get the same network stack, they get the same various other namespaces as well. So they're very tightly put together. A service is what gets exposed. So I created 3 services there: a Redis service, a back-end and front-end, and a front-end web service. So basically it groups the pods together, and Kubernetes then says, the service gets a stable IP address. The pods, they could be created, they could be deleted, they could be moved. You don't need to know any of those things. You talk to the service. The service stays put. So that's an important one. And nodes are just nodes in my cluster. So you've got a number of nodes that make up a cluster. You've got kind of masters and slaves. We'll talk about that in a second. So how does it all do it? Right? We've done this very cool thing. It all just worked. Do we need to know how it works? Well, this is how it works. So basically, the API server right in the middle. Woo, fancy. The API server right in the middle, that is the beating heart of the cluster. If you look at all the lines on the diagram there, they all go through the API server. Everything talks to the API server. It doesn't talk directly component to component. They all go through the API server. So from a security standpoint, the API server is obviously our key goal, right? If we can control the API server, we're going to compromise the cluster because that's where all the stuff goes through. However, Kubernetes clusters are stateless. So the API server doesn't store its own state. It doesn't know anything about how pods are put together. It stores it all in etcd. So up the top, you've got that, and that's a key value store. And you'll generally get a cluster of those. So you'll have a cluster of etcd stores, and what they do is they essentially store all the configuration of the cluster. So from a security standpoint, if I can get to that, that's bad too, because I can drag out the entire configuration and I've got all the secrets and everything else that goes into your cluster. And then down the bottom there, so that's our control plane, those three components there. Down the bottom, we've got our worker nodes. So they're the ones that actually run the application. And probably the most interesting component there is the kubelet. And the kubelet essentially talks to the API server, and the API server will say, go and create me some containers, go and create this, use this image, use this Docker image, run it up, expose this service, do that, do this. And the kubelet handles that on each worker node. So obviously if you control the kubelet, you can run containers, which again is going to be bad from a security standpoint. So those are our three main ones. And then the container engine over there on the right is generally Docker. So Docker sits underneath all of this. You don't have to use Docker, but most deployments use Docker. So that's how it all hangs together. One other thing to mention about this is networking, because Kubernetes networking is kind of weird. When I roll out those containers inside that application, they all get to talk to each other across a flat network. No matter what underlying node they are on, they can all see each other and they have their own addressable network. And it is a flat network by default, and it doesn't have any firewalling by default. So typically, anything on the cluster can see anything else on the cluster, which has obviously security concerns. Because some assessments I've done some assessments of container networks, and people might make the mistake of assuming that that container network's trusted. So they'll put things like MongoDB instances with no passwords in the container network, assuming you can't get to them. Turns out not to be true in some cases. The other weird thing about it is Kubernetes doesn't do its own networking. It assumes for some reason that you'd want to use a plugin for that, so it passes it off to third parties. And you'll see things like Weave, Calico, Flannel, Romana, lots of projects with kind of weird names, and they provide various different ways of doing networking. But the advantage is clear because it means that I could have a cluster running on different cloud providers. I could have different nodes in different clouds, different networks. But as far as the apps are concerned, they're all on the same addressable network. Very important in terms of making the thing work. Oh, and deployments. Yeah, I mentioned this before. This is a word cloud I made of all the different deployment methods I could find. If there's a spreadsheet that gets maintained. There are 66 different either corporate supported or open source projects which give you ways of deploying Kubernetes clusters. They vary from just like bash scripts that deploy the components all the way up to platform as a service. So something like Red Hat OpenShift puts a whole lot of stuff on top of Kubernetes. The thing about security that is they all have their own idea about what secure means, and they all have their own idea about what default security option should be in place. So if you're assessing a cluster or thinking about deploying it, probably the most important thing is what are the defaults that my cluster deployment method chose? What did they think I had to do from terms of security? Because once it's up and running and you've got production workloads on it, let's be honest, a lot of this stuff's really hard to change. So what secure defaults you choose is probably the most important decision you're going to make when you're rolling this stuff out. And if it's the one thing you think about, take away from this presentation, is that's really important because I did quite a lot of, when I was looking at this, I got various default install mechanisms for open source projects and from cloud mechanisms, and I installed them, and I got some interesting surprises about what some people think secure default should look like. Major cloud providers think their default security option should look like. Definitely not what I would choose as secure. So let's talk about some of those. Threat model. Threat model is super important. If you never get attacked, doesn't matter if you're secure or not, right? You can have the worst security in the world if no one ever tries to attack you. Who cares? But there's obviously, this is the real world, and systems always get attacked. But who's going to attack a cluster? External attackers, right? If you deploy your cluster on the cloud, then it's going to have some sort of internet accessible component, so someone's going to try and attack it. If you deploy your cluster in a corporate network, you're on a WAN, people can attack systems on a WAN. External attackers are a fact of life. This one is a wee bit more interesting. What about an attacker who's got access to one container? So you've rolled out an application into your container, it's got a security flaw, the attacker gets access to that one container. How hard or easy should it be for them to get cluster admin once they've done that? This one is weird because this is the one I have a difference of opinion with some people who make Kubernetes deployments. Some people don't think that's part of their threat model. So when I say that they will deploy clusters, they'll say the default option basically, if someone gets access to one container, cluster admin should be trivial, and is trivial, like really easy, and we'll see that. And that's where I have a difference of opinion. That's why I'm saying be really careful when you're choosing your when you're choosing your Kubernetes deployment method. Make sure that if you think that's a problem, that they think that's a problem. And the last one is, what about an attacker who's got rights to run a container? So if you work in a really big company and you start rolling this out across your corporate, you might have groups of people who you want to be able to use it, but you don't want to give them cluster admin, right? You don't necessarily want everyone to be able to get full control of your cluster. So how easy or hard is that going to be? External attackers. So we'll start from the outside world, right? We're going to start as a point of view of someone who's trying to break into this cluster from external. So, what do you do? As soon as you try and assess the security of a network system, you port scan it. At least that's what I do. And if you port scan a Kubernetes cluster, you get lots of potentially interesting things. So we've got 2379. I mentioned etcd. So that's the default port for the key value store. If you see that, that means they've got a clustered version of that running. So they're listing on a network interface, and you can try and attack it. We've got 4194, which is CAdvisor. The one below that, which I've got kind of in brackets 6 and 8, it's because they can't make up their mind what port to run that on. Some run it on 6443, 8443, or just 443. That's the API server. Everyone knows that's kind of like the most important one. The next one's kind of interesting. 8080 is the insecure API server. That's what it's actually called. And you can guess from that that it may not have the best security in the world. And I have seen that exposed inside a cluster by default. So anyone in the cluster can just go 8080, thank you very much, and we'll show you that in a sec. 10250 and 255 are the kubelet, so we've talked a bit about that. And then various, so that depending on what network plugin you go for, you're going to get various ports there. Some of them do, for example, they'll use BGP, so you'll see the BGP ports open. You wonder what the hell? This is an internal system. They use BGP to manage routing. So that's interesting in and of itself. Some of them will have their own etcd instances for managing their configuration. So you'll see another port of etcd being like 4001 or something. So let's do some more demos because, you know, why not? First one up, CAdvisor. I actually got this loaded. So CAdvisor is installed by default in most Kubernetes clusters I've seen. It's unauthenticated, and there is no option to make it authenticated. So if it's there and it's running, it is available. And if I'm an attacker, I'm kind of looking at this going, you know, can't command execute, but you do get cool stuff like, this is a list of all the pods that are running on this host. And there's the Docker version that's running, there's the kernel version that's running, there's the operating system version that's running, some directory information, that's quite handy. And lastly, some nice version information as well. So you get some nice information disclosure out of that. And that's pretty much, if you find that port open, it's going to be available, it's unencrypted, it doesn't have SSL, and it's never authenticated as far as I can see. So that's a nice good starting point. Not the end of the world, but you know, kind of handy. What do I do next? Don't need that. Got that. But let's talk about the kubelet, because the kubelet's kind of more interesting. There's two different ports before I mentioned. 10255 is read-only, right? Read-only again, the read-only port, it's enabled so that services can hit it for management and diagnostics. It's pretty much enabled in every cluster I've seen. It's unauthenticated on every cluster I've seen, and it's not encrypted. So, and what can you get out of that? You can kind of get some more interesting stuff. Where are we? Kubelet. Yay. So everything, it chucks out things in a very nice kind of like JSON format. So you can basically hit most of these APIs with a browser or with curl, which is really cool if you're testing them because it makes it super easy. And if you've got Firefox, it gives you this nice. And this is what you get. This is unauthenticated stuff. This is a list of all the pods running. But there is one kind of thing I wanted to mention specifically, which is if we search for API server, this is the manifest of the API server. And the interesting part is this. Every Kubernetes configuration option is passed as a command line parameter to the component. That's just the way it works. So if you get that dumped out, you can get every single piece of information about how it's configured, which is kind of nice and handy. So it tells you things like what ports things are running on, what files. So there's the service account key file. So that, for example, is a private key for communications. Now you know the file name. So if you get some other vulnerability that lets you read files, you know where to go to get it. So again, this isn't catastrophic. You're not going to get end of the game. But it does tell you lots of information. I know what authorization mode you're running in. I know what ports you're binding to. I know what services you're running. Again, pretty much on every cluster I've seen, if you can get to that port, it's unauthenticated and it's unencrypted and it's available. So that's kind of useful. No, do need you. Okay. Right, however, more interestingly, kubelet read-write. This is more interesting. First off, the read-write port, it's SSL, which is nice, although it uses internal certificates in this case. You can dump the log files of any, if you can get the read-write port. Now, before, like 2 versions ago, which is only 4 months ago, this was unauthenticated by default. And indeed, before, another version before that, there was no option to authenticate it. It wasn't possible. So as of before, about the start of this year, you couldn't have this authenticated. For starters, you can do this, which is kind of cool, because you can dump out all the log files from the server. That's quite nice, but again, it's not catastrophic. However, yeah, I'm going to go and copy this, because I never remember this command off the top of my head. Like I said before, you can hit these things with curl. So what I should be able to do is Control-C. Okay. So what I'm doing here is I'm posting to an API, and I'm posting to the Kubelet API. What's interesting, so I'm hitting, and what you can do with it is you can run commands, right? And you can run commands on any container running on the node using the Kubelet API. In this case, what I'm going to do is I'm going to cat out, you see the end, the commands here at the end, I'm going to cat out /etc/kubernetes/admin.conf. That's got the key for authenticating to the cluster. So if I can get that file, I can use that then to authenticate the cluster, game over, and the cluster admin. And hopefully, yeah, that works. So that's me. If you get that port, and you can run that command, you can take control of the cluster, because that's the token that lets you take control of the cluster. Until a couple of versions ago, that was available by default, which is not good. So if you're using older versions, upgrade. So yeah, that's the first one that's like really, really bad. And that's the kubelet. The kubelet basically, if you can get to on a node, lets you run commands. It's not going to be good news. And you can run commands inside containers. So let's talk about malicious containers. Let's talk about malicious containers. So we can have a container that's malicious. And I mentioned before there's a bit of dispute about how serious. I personally think this is a bad one, because I've seen too many cases where I'm a web app tester a lot of the time. You get some form of command execution via web app. And at that point, you're inside the environment, you can execute commands. To me, that's not a scenario where I should be able to go and take over a whole cluster. It shouldn't be easy for me. It should at least make it difficult. We've got an increased attack surface at this point. And there's a couple of different ways that's relevant once we're running on a container. We've got container file system access. So we've got access to a single file system of the container we're running in, which is bad for the app, but it could also be bad for the cluster. We've got this internal network position. So before I mentioned the fact that there's this nice flat internal network, that's good for us as an attacker, because once we're in there, which is great. And there's kernel attacks. Containers all run on a node. Obviously, one of the key things about Docker and everything else is you're running against a shared Linux kernel. So if there's a 0 day in that kernel, or you're running an old kernel, once I've got the opportunity to run code on it, I might be able to get in that way. But let's talk about service account tokens, because they're really wacky. By default, Kubernetes, up until, well, actually, yeah, you can stop it now, but basically anything before 1.6 allowed it by default, definitely. When you run up a container in Kubernetes land, it gives it a token, and it gives the container a token so that it can communicate back to the API server. So maybe it wants to talk to the API server to do something. Maybe it wants to get some stats or talk to the API server to tell it's deployed itself or whatever else. The weird thing is that by default, until recently, those tokens were cluster admin. So if you get inside the container, you've got a cluster admin token, which is nice if you're an attacker. So what we'll do here is we're going to deploy a container to simulate our bad container. This is our compromised container. Right? And we call it bad container because, why not? So we've got our bad container. And now I should be able to do kubectl exec xit bad container. Cool. That's us inside the container. So now I'm on the container network. I'm back out. That's me. I'm now running as my container. And I'd like to say there was some long, complex, elite process that I needed to carry out to do this. But I hate to say that works. If you've got the kubectl binary inside your container, there is a token in a default location that it knows to pick up, which it will get. And Kubernetes handily sets environment variables which tell it where to find the API server. So it just picks up the environment variable, says, where is my API server? Oh, right, it's there. Then it goes and says, can I have my token? Yep, that's there. And then it runs. And then you're cluster admin. Not very elite, very easy to pull off. I'll talk about how to get rid of it, but basically, you need to not be mounting service tokens inside containers at all under any circumstances. If you do, you have to be using authorization to lock it down. Otherwise, that happens, which is bad if you've got a cluster. So service account tokens are super dangerous. And actually, it was kind of fun. There's a B-side San Francisco write-up. I don't know if anyone saw it. So they ran their CTF this year in Kubernetes as a cluster. And of course, in a CTF, the job is to get flags off boxes, right? So they had them all running as containers. And one bright spark popped the first one, got the flag, went, hang on, this is a Kubernetes cluster, got the service token, got cluster admin, won the CTF, got all the other flags, bam, in an instant, because they didn't know about the fact that service tokens are cluster admins. That was a surprise. API server attacks. So yeah, so in this case, and I have seen this from inside a cluster as a default option in a major cloud provider, you get 192.168.111, oops, 111.10. Let's not do all ports, otherwise I'll be here forever. Yeah, so that you will see sometimes you'll see the insecure port open. If you see it open, it's super simple. You just do kubectl -s http. So you can just point at the insecure API server. So basically, if you have a port 8080 open, you can use curl, and you can do all this stuff with curl because it is an HTTP API. But frankly, if I'm attacking it, I'm going to get kubectl down just as the binary. It's a static Go binary, so it's really easy to get hold of, no dependencies, and just run it because it's much easier getting stuff back out. And the format's kind of funky if you start doing anything complicated, whereas kubectl is super easy. So yeah, if you see the insecure port, game over again. It's always cluster admin. And etcd. Last one is etcd. Etcd is interesting. If it's open, you can dump that out as well. So let me get the command for that because I'm not going to remember it. So basically, there's a command called etc control, which you can use to dump or to interact with etc databases. It used to be that it was a nice HTTP API in older versions, and indeed if you get an older version, it is an HTTP, and you can hit with curl, and you can just do recursive gets and just get all the stuff that way. They've moved to a binary format now, which is a bit less friendly, but you can still do something like that. And if it's not authenticated, that saves a file called test.db, and then you can use a thing called Bolt browser. It's this weird Bolt format, which I've not seen before, and you can just do that, and then that's the entire configuration of the cluster. Just sitting there. So it's in this kind of slightly weird, you can see the question, it's in this kind of weird binary format. So if you want to really get hold of it, you'll need to deserialize gRPC, which is what it is. But frankly, if you're just dumping stuff, you've got way enough information to get. There's tokens and stuff in there if you look around long enough. So that's a really good one if you hit a port. And the interesting thing about etcd is if it's authenticated, it only has one option to be authenticated, and that's client certificates. So the way Kubernetes works with etcd, it's all or nothing, and it's authentication based on client certificate. But it trusts, basically it has a trusted CA, so it has a trusted certificate authority, and it says any certificate issued by the certificate authority I trust is cool and can download the file. So if you use a certificate authority for a number of different things, including etcd, anyone who can get a client certificate can hit it and dump the configuration out. So you have to be a wee bit careful with how you configure the certificates for that. But it's cool too. Attacking the OS kernel. Basically, this is just standard Linux kernel stuff. If you get onto a container, they're running old versions of the kernel. You probably got that out of CAdvisor or something like that. You can look for things like dirty cur or some of the other Linux exploits that might let you break out. But that depends. That's environment specific. So malicious users are obviously... Malicious users are harder to stop, right? It's going to be harder to stop people, but you might have circumstances where you've got a set of people, you don't necessarily want to give them all cluster admin, right? You might want to say, oh, you can do this, you can do that. By default, in older versions, definitely that was just not a starter. You know, you're cluster admin, and that's just the way it is. But I'll talk a little bit about it because kubectl, you've seen me, so I've used kubectl for everything here, and I did see one talk where they were saying that the people rolling it out were saying we don't want to give the developers SSH access to the cluster, we'll just give them kubectl. Problem is, you've seen me exec into a container. kubectl is SSH, it's everything. You can turn it into a proxy, you can do all sorts of stuff. It's a really cool program. But if you give someone kubectl access and you don't lock down their rights, they are basically going to be cluster admin very quickly. Because, I'll show you a little example. There's a concept in container land of privileged containers. And basically a privileged container says, turn off all the isolation that Docker provides. Just give me root like I'm on the node. So if you run a privileged container, then that's bad. Kubernetes has an option called allow privileged, which says at an API server level, I can just say, no, don't do it, don't allow it. Allow privileged is on in every single deployment I've seen. And the reason it's on is certain system components need it. So basically it will be enabled. So here I've got a little container which is privileged. And what you can do is, with Kubernetes containers, is you can basically say, I want to mount in stuff from the node. So by default, so I can just say, mount in a host path of the root into /node, and I can do something like this. So exit back out of my bad container, and then we'll do create -f protbod, and then we do kubectl exec it. Okay, and what I've got here essentially is in here, that's the root file system of the underlying node. And if we look at who I am, I'm root. So it's game over for that node. And if it's game over for the node, unless you've done a lot of configuration on your cluster, it's probably game over for the whole cluster, because the kubelet has got certificates in it which allow it to talk to the API server and allow it to do things to modify the API server. So that's probably game over, and I can add users, do whatever else I want, just by mounting in the file system. So basically, if you let someone run containers in an unconstrained fashion, and you just basically say, I'm going to let you do whatever you want, if they want to be, they'll be root really, really quickly on your cluster, and there's not a lot you can do to stop them. Access to nodes is super bad, basically. So yeah, in general, that stuff, not good. So how are we going to fix all this? So I've kind of basically told you about how to break all these things and how to totally destroy clusters. It all comes down to what options you choose and what versions you run. It's getting a lot better. When I started looking at this like 9 months ago, a lot of these options didn't exist, and basically there was no way to stop a lot of these attacks apart from lots of firewalling and trying to stop people getting to the ports, because if they could get to the ports, it was going to be super bad. Not so much the case now. For starting, turn off the insecure port. The clue is in the name. Do not enable the insecure port. It's a really bad idea. If you absolutely have to, bind it to localhost on the API server. That at least gives you some degree of it'll be harder for someone to get to. But generally, I would say get rid of the insecure port. It's not a good idea. API server authentication. This is kind of interesting, right? So obviously turn off anonymous authentication. That's, again, kind of an obvious one. Authentication to Kubernetes is kind of weird. It used to be you used basic HTTP auth or token auth, which were static tokens which lived in a file on the API server in the clear. This obviously isn't ideal. If you wanted to add or remove a user, you had to go in SSH onto the API server, modify the file, and reboot the service. This is not a scalable authentication mechanism. So these days it uses client certificate authentication. You notice when I was running all those kubectl commands, that wasn't that I disabled authentication on the cluster. It's just that it knows where to get the config file to do my client certificate to pass it to the API server. The one problem with certificate authentication that I think should probably get mentioned is, within Kubernetes itself, there is no certificate revocation as a concept. So if you lose someone's certificate, you either have to recreate the entire certificate authority or live with the risk until it expires. So either use short-lived certificates or have some other means of doing certificate revocation. You can use external authentication services, and that's probably the most flexible option right now. So it'll do things like you can have a webhook, and you can tell the API server, go and talk to this webhook to do authentication decisions. All the other ones are a bit kind of, I wouldn't want to scale them. They're okay for small numbers of users, but if I had like 100 users, I wouldn't be using client certificates like that with no revocation, because you're just going to end up with someone loses their laptop and it's like, oh, smeg, what do we do now? That's not a good situation to be in. Authentication is kind of odd. Authorization. So it used to be once you're in, there was no authorization. It was cluster. If you're like 1.5 or earlier, it's almost inevitably there's no authorization. Now there's RBAC role-based authentication. It's worth, definitely, that's the way to go. So you want to lock down what users can do. You want to start applying role-based authentication to those users. The only thing I'll say is it can get a wee bit complicated. Just to give you a demonstration. kubectl get cluster roles. This is a default kubeadm install. That's the list of roles. And that's not, although actually there's more roles, there's the ordinary roles as well. Actually, I can't do the other ordinary roles. But yeah, there's cluster roles and cluster role bindings. And there's like, what is that? I don't know, 30, 40 of these things. So it gets a wee bit complicated. So I will say that, if you're starting with a lot of users on a cluster, thinking through how you want to do your authorization and getting that right early on is probably really important, because you're going to end up with a really complex situation. And the funny thing about Kubernetes is it doesn't have a list of what users it knows about. So if you said to a cluster admin auth, give me a list of users, don't know. It's just down to the certificates are presented. The certificate's presented, it has the name of the user in the certificate fields. That's how it knows who you are and what roles you've got. they don't actually know who all the users are. The cluster can't tell you that. You have to be your CA authenticator or whoever else manages your authentication service who's going to know that. So you can end up with a bit of mess, I think, down the line. So that's, yeah, but definitely use RBAC. Don't use anything else, use RBAC. It's the way forward. That's definitely where they're heading. Control access to the kubelet. Turn off anonymous authentication of the kubelet. Absolutely. Set the authorization mode not to always allow, which is default settings in older versions. Turn off the read-only port and turn off CAdvisor. If you absolutely need these things, bind them to localhost, firewall them off. But you've seen you can get information that an attacker is going to be really happy about finding if you leave these things open. So definitely turn them off. Control access to ECD. So I mentioned it before, the certificate authorities in ECD are a bit funny, so you have to be a bit careful there. But absolutely try and control access to that as well. Other things to think about. So when I was running out that pod there and I said, let it be privileged, until recently you didn't have a lot of choice to lock that down. But there's now a thing called pod security policy. Apply pod security policies to all your pods. Basically, you can say no privileged, no mounting stuff off the host, no doing things that are dangerous, no adding yourself extra rights, no binding to the host network, no doing any of these things. So you need to define a pod security policy for any pod you deploy onto the cluster and get that stuff right before you start deploying things. Security contexts. So containers, both Docker and everything else, they kind of have an idea of what they're going to do as default. They say, here are your default security options. You can harden that stuff down. You can make it, you can give the thing less rights. You can take away capabilities. You can add AppArmor or SE Linux policies. If you're rolling out a cluster, I would well worth looking at that. I'm not going to pretend it's going to be super easy to do, but if you have a high value cluster, you start using stuff in production, it's worth looking at. And the last one, which is pretty new, it only came out into production in release version 3 weeks ago, is network policy. So network policy stops the problem of everything can see everything else. You can apply essentially firewall ACLs to containers. So you can say, I'm going to define a network policy. This container can only talk to these containers on these ports. It's not super flexible yet, but it's absolutely better than having nothing and having this big flat internal network that everyone can talk across. So resources. There's a couple of things to look at. There's the CIS guide, absolutely worth looking at. This is something I've started writing. Oh, have I got enough time? Yeah, I do. This is something I've started writing, so I'll kind of show you briefly. No. Where am I? Oh, yeah, here. So I've started doing a little analyzer tool, which basically gets the CIS guide and tries to actually turn it into a report. This is a demo. So it will go through and it will check, essentially, pass or fail on each one of the checks, which is, but what I've found is, and it also dump out all the evidence, so it says, why do I think that's the case? And I've started putting in some vulnerability checks, so things like unauthenticated kubelet, we talked about, look at that, internal access, API port access. The only thing I'll say about this in writing this, and if anyone likes writing Ruby, because I write Ruby because it's the best language, if anyone likes writing Ruby and is interested in doing more of this, what I found that's complex about this is, I remember I mentioned the 66 different deployment options. It turns out each deployment option makes it harder to check. So some of these things will deploy everything as containers, and you can query the container and get the information you need. Some of them will deploy it bare node. Some of the cluster options, like Google Container, don't let you see some of this stuff. They manage it at a cloud level. So it's a bit trickier to write, but that can work for certain deployment options, and it's a nice, easy way of saying, give me a quick check to see what's going wrong. Cool. I was going back. And of course I went to, I'd do that at the end. I knew eventually I would end up going. There we go. Conclusion. Right, so what I would say in conclusion to all this, the security model of Kubernetes is kind of like where Docker was a year ago. Docker had this period where it rapidly added new security capabilities and got a lot better than it was. And a lot of the very early stuff about Docker's horribly insecure went away as they added these. Kubernetes, to me, is going through that same process of adding capabilities and adding things that at least you can configure it securely. What I would say, however, is that not all the different people who are deploying Kubernetes decided to deploy all those things. So a good example of this is RBAC. So RBAC, as I've mentioned, is kind of complex. I know that several of the big Kubernetes distributions aren't putting RBAC in yet right now because it's too complicated and they don't want to do it because it's a lot of work and they've got other things to be doing, and if it's an open source project, they don't have time. So you have to be careful when you choose how you're going to deploy Kubernetes, which one you choose, because some people don't, think that's a priority for them. It's getting better, however. It definitely is getting better. They're adding more things to it. And always think about your threat model and attack surface when you're deploying this stuff. If internal containers are a concern for you, make sure you've thought about that and you've applied it. If they're not, then fine. Yeah. Questions? Yeah. Okay.
Does Kubernetes provide any sort of network level security for the actual internal networking? So, IDSs, that kind of thing?
There are people doing add-on products. They don't do it. There's a lot of what I'm finding at the moment is a very early days, but you're starting to see a couple of cluster-focused security startups who are looking at things like IDS inside a network. It is a bit of a problem though, because one of the things I realized is that traditional IDS probably won't see anything on the overlay network, because the overlay network can be encrypted and probably should be encrypted. So yeah, you'll blind low-level network sensors. I haven't seen anyone there's nothing's kind of coalesced like this is definitely the way to go. The first part has been network policy coming along, and you can now actually apply ACLs, which is a huge step forward in terms of locking it down a bit. But no, I've got anything specific in terms of products. Yeah.
Quite a few times you talk about the defaults, like security defaults.
Yeah. So if I was picking one on security and just security, I would probably pick OpenShift, Red Hat OpenShift, because a lot of the stuff going into Kubernetes from a security standpoint has come from Red Hat, and they've essentially had their own implementation, and now they're pushing it upstream into Kubernetes. However, obviously, that if you want to go past the basic options, that's a paid-for platform. So they have an open source version, but it's kind of like, that's obviously not, I mean, to be fair, they've got to make money out of this. So their main thing is the deployed option and their hosted options, and it's a paid-for product. But definitely, they have thought these things through and applied lots of things. Like they had network policy before Kubernetes Base did, and various other ones. kubeADM, which is one of the other mainline options, it's quite good and it's getting better. And it's applying more. It seems to be applying almost. I feel that's the base. kubeADM is where everything should be. So they're not bad. The other one, if you're going for a hosted option, Google Compute Engine or Google Cloud Engine, I forget what the Google Compute Engine. Basically, Google's container one is probably the best, just because it's Google's project, honestly, and therefore they have a lot of the people who are helping to write it. So sometimes they tend to be ahead. But it's a slightly different game because you're quite tied into their cloud at that point. So it depends on whether you're a heavy GCP user or not. Yeah.
In terms of, you mentioned earlier the authentication layer supporting, for example, web fonts. Is that standardized to, say, SAML, or they follow the standard in that aspect?
I don't think they're prescriptive about it. I think they kind of let you basically, you return a fail pass, and so how you're going to do that is kind of an implementation issue. They're not. It's kind of funny. They've obviously decided where they want their boundaries of responsibility to be, and for me, having a database of users and managing that would be part of what they do. But they've said, no, we're not going to do that. We're going to pass it off either to certificate authorities or to these external third parties. So they've kind of said, no, that's not us. So yeah, I don't think they've actually dictated a path through. So.
Have you looked at any other Docker orchestration technologies, Swarm,
yeah.
and such?
Swarm I've looked at quite. The thing I would say about if I was picking between Kubernetes and Swarm is better out of the box in that it's a lot less complex. So all these different services I've been talking about, all these different attack points, things you can get your teeth stuck into and break. Swarm doesn't have any of that. It's got one port and it's authenticated by default, and you're not getting it in a hurry. The only thing I would say about Swarm, which puts me off a little bit at the moment, is they're missing security profiles. So I was talking about you can apply pod security policies and lock down what can be done. Swarm haven't done that yet. They had it in Docker Run, but then when they went to Swarm, it's still in development. So you can't, in the open source project anyway, you can't actually say I'm going to lock this container down by removing some of its options, which is a bit of a shame. But in terms of simplicity, it's way simpler and less complex. And if you don't need the scale of Kubernetes, I would say Swarm's a much, if it works for you, it's a better option. Just from a security standpoint anyway, not any other standpoint.
Good questions? Brilliant.